Okay, well, we're going to go ahead and get started. Everybody hear me okay? I think we got the mic issue worked out. So my name's Casey Smith. This is Matt Nelson. So we're going to be talking about Windows operating system archaeology. We are going to be talking about the component object model today and COM, which has been around in Windows for a very long time. And so we're going to take a look at it from an offensive perspective and a defensive perspective. So we found a lot of ways to abuse COM functionality. These aren't exploits. These are things that are built into the way COM is instrumented. So just briefly about myself, you can connect with me on Twitter @subt. I recently joined the Mandiant Red team. I have a blog post there, the URL. So feel free to connect with me on Twitter if you have questions, or we'll be around for the rest of the weekend and at the after party. So things I really enjoy researching are like whitelisting bypasses or interesting ways to get things to execute. So.
Yeah. And then I'm Matt Nelson. That's my Twitter handle. I'm a operator and security researcher for Spectre Ops. That's my blog. I don't have nearly as awesome of a background as Casey does. I used to be a sysadmin while I was in college, and then I graduated and then came to work for security as a consultant. So nothing crazy.
Okay. So what we hope to come away with for objectives for this talk, really, we wanted you to start looking at COM the way we do. Like we really have maybe an unhealthy obsession with weird COM objects. But we think it's important from an operator for as a red team, because these are things you can use that are built in native to the operating system. And so we wanted to foster the curiosity and get other people researching this along with us. The other thing we wanted to do is provide several references. So there's a lot of documents in here. We're going to post some of our code snippets and the slides after the talk today. So we wanted to get this sort of on the record so you guys have a resource to come back to for COM. And then call attention to the attack surface. So a lot of interesting ways that you'll see when we get into malicious COM tactics that you can execute code on a system or remote system. So, cool. All right. First, we're going to talk about COM overview, so to set the ground so everybody at least understands what it is, a brief overview of the history. We'll talk about our research methodology, so how do we go about poking around and looking at things inside of COM to learn, so we really want to teach you how to do that. And then also the malicious COM tactics, ways to execute things that you may not expect or would be difficult for a defender to detect. So the COM overview is just a very, very brief background. I would reference James Forshaw's talk that he did at Infiltrate this year, or Troopers, if you want a good 30 to 40-minute overview of COM. So I don't want to repeat some of what he's presented in his talk, and there's a reference for that later. But the two main things we want to look at are what's called COM registration and resolution. So how do you get an object onto a box, and then how do you create those objects when you're ready to use those inside of an application? So, all right. Component object model, it's been around since 1993, maybe older than some of the people in this room. So the idea here is this is not a new technology in Windows, and Windows is heavily dependent on COM. Explore.exe, for example, if you ever fire up process monitors from sysinternals and look at all the objects that are being resolved, it's substantial. So there's a lot of embedded activity going on with COM that's been around for a long time. So that's why we call it the archaeology. So really, really brief history of COM. How these objects exist in Windows. There's a number of file extensions. Some of these you've probably heard of. Others you may be new to you. So you essentially have like DLLs, OCX, type libraries, executable files. And recently there's a file that we've been working with called SCT files. How many of you have heard of SCTs or seen SCTs? So a couple of you have seen these. These are XML files that actually let you create COM objects and run VB or JScript. So the reason we talk about SCT files is that's something that Matt and I use quite a bit. When we're doing a quick proof of concept on how to get COM execution, we usually whip up an SCT file, either locally or hosted on the internet, and get that to run. So I'm going to show you in a minute what an XML SCT looks like. And then COM has this idea of location transparency. So the idea is that as a developer, they wanted it to be an easy-to-use way to instrument objects. So whether that object is in the same process, in another process, on another computer, the calls and method calls all look very similar at the binary level inside of COM. So this is an example of an SCT file, COM scriptlet file, and it was a way for you to back a COM object, not by a binary on disk, but by a text file. And you can see one way you might call a COM object like this is using a tool called regsvr32. And I'll reference my blog if you want to learn more about that. But what's interesting here is The XML definition is at the top, really the first 8 lines of code. But the object itself is going to run lines 9 through 11. So whatever you can do in JScript or VBScript, you can do inside of a COM object without calling the C script or Windows script host WScript. So I'm really interested, and we'll talk about this later, like how do I then expand the capabilities of JScript or VBScript? So those are some things we'll look at.
The class IDs that you make it your own class ID?
You can. Yeah, the idea was that should be globally unique. So that it's a GUID that you can generate. There's an API call to generate one unique to that system or unique across time. So I generally make them up as I go, but yeah, it can be whatever it wants to be or should be followed. If you're designing COM objects, you follow the right pattern to create those. Yep. So the question was just, is the GUID unique or does it have to be unique for the system? So
we'll go over some of the implications of using the same class ID, duplicating it and kind of interfering with the flow.
If I can give you both a microphone real quick.
Oh yeah, sure.
Put that on.
Okay, awesome.
That one doesn't work.
You sure?
Yeah.
Okay, if you can just try to share that one back and forth.
Okay, we'll do that.
It'll help for the recording.
Oh, thank you. Okay. All right. Is that too loud? Is that okay? All right. All right. So the way that COM resolves objects, I feel like that's so loud, is there's 2 registry hives. So there's HKLM, HKey local machine. There's HKey current user. Those combine into a registry key called HKey classes root. HKey classes root really is a blend of both of those. And I think you said it well. It's like a virtual class. So the idea is when you're searching for something for COM, the thing that's interesting about finding these objects would be per user COM objects where they're resolved in HKey current user first. You have to be an administrator to write something to HKLM. So that's what's interesting here is if you can create something in HKCU that would hijack or allow you to get access to execute your code instead of what was intended for that COM object. And Matt will go over some of those tactics in a moment. So really just put this slide in for reference. So those of you who are blue team or defenders looking at COM objects, what are those paths or what are all the different attributes that a COM object would have? So this is really just in the deck for reference. There's a couple good MSDN articles that describe exactly what keys are needed for a COM object. So some important components in COM object resolution. And so we'll go over in this slide a couple of things that we want to look at as far as like class ID we mentioned or CLS ID, which is a GUID, can be made up. I generally make them up because I'm just writing proof of concept testing. But again, we talked about how those can be generated with an API call. Program ID is a string, so a friendly name for the COM object that you would use to instantiate it. So like scripting.dictionary or wscript.shell. Those would be the prog ID associated with a COM object. The monikers would be the way you're going to invoke the instance of that object. So like, for example, that moniker there says scriptlet :HTTPS. So it's saying, go find a COM scriptlet at this URL and create that COM object. And so COM is really instrumented to go fetch this XML file from the internet, execute it on the system inside of Reg SVR32 or some of the other tools. So this really, really fascinating way to look at monikers and how they're used to create those objects. The 2 calls that we're going to abuse quite a bit are getObject and createObject. And so it's important to understand that you can pass, when you call getObject, you could pass that scriptlet moniker to that function call and it would create that object. And so here's some examples of how to do that with like run DLL32. You're calling getObject and you pass that path, it's going to go out and fetch that COM definition and create it in memory for you. So there are other monikers. So there's WMI monikers. So like Win Management System or something like that. Those are other. There's a bunch of these on the system that can be used to invoke different calls. Here's really like we did a search like the other day. Just like here's one COM object that's got half a dozen or so different keys. Some of these are more important than others in terms of abuse of a COM object. But that's what it looks like in the registry hive. This is in HKLM. We've got the class ID, and then we've got different subkeys that will define like what DLL is loaded, where's the scriptlet defined, treat as, which Matt will go over in a little bit later. So that's what you would see in the hive if you're querying for COM objects. Typically, developers, when they create these COM objects, they'll use a couple of tools to register the COM object. And this is where I found a number of like whitelisting bypasses is by abusing these 3 tools in general. So reg SVR32, reg ASM, or reg SVCS. Like if a developer writes a COM object in .NET, they want to register it, they would use one of these tools that would then create all of those keys in the registry for you. So, wanted to take you through it briefly just so you get a sense of what's happening when you go and execute a COM object. These are some of the different calls or function calls that happen. This is from the COM specification from 1995. You really want some gripping reading, tear into that document. But you can see that the function calls in the client would be, first it would call essentially, I want to create an object, so create instance, which is then going to go figure out in the registry, which is like step 6 down there. Look in the registry, find out which DLL contains this COM object, load that object into memory, and pass back a reference to that object to the client that called the COM component. So looking up in the registry is an important artifact as a defender to see, well, if they called or created this object, where is it in the registry? Because you often have to persist that definition on in the file or the registry system. So, all right. Normally, until Microsoft came out with this thing called registration-free COM, which we'll talk about, which allows you to create COM objects that do not exist in the registry. Now, that's important as a red team because I don't want to put registry keys on disk or in the registry. I want to create an object and run a DLL or execute something without leaving those artifacts behind. So registration-free COM is the tactic that you can use to do that. So there's a couple different things that we've found that we can use to avoid registration of a COM object. So the COM object normally lives in the registry. I'm going to present 2 or 3 techniques that you can run a COM object without those artifacts. So first of all, the goal here would be inside of VBScript or JScript, how could I load a .NET DLL and execute it? The reason I want to do that is because JScript and VBScript by default don't have Win32 API calls. So I can't like run a shellcode blob in a VBScript normally. But if I can get VBScript to load my .NET assembly, which gives me full access to the Win32 API, now I can run shellcode in JScript or VBScript, and that's interesting to me. And so that's what these 2 or 3 tactics that I'm going to talk about allow us to do with a COM object. So imagine somebody runs reg SVR32, it reaches out, pulls down a text file, and execute shellcode. I mean, that's what the capability we're talking about here. So go ahead to the next slide. So the first one is this activation X or activation context. So ACT-CTX object. Okay, it's built into Windows. You can create it. I'll show you some example code I've got on my GitHub page. It requires 2 artifacts to be on disk in order to get this trick to work. So first, you'd have to drop the DLL, and second, you'd have to have a manifest, and then you would just say, okay, I'm going to create the ActiveX object, tell it where the DLL is, and then it will load that .NET DLL into the process without having it all those COM, class ID and all the registration components in the registry. So there's an example of that on my GitHub page. The next slide shows the code. It would be like 3 lines of code. So in this example, I've used this quite a bit. Like we take a tool called certutil, we encode a file to base 64. Drop it to disk, use certutil, decode it to a binary, and then you can call these 3 lines. So activation, the first line on line 352, create that object, point it to the manifest, and now you've got access to the Win32 API using a tool, in this example called Dynamic Wrapper X, which is a DLL that gives you some pretty fascinating capabilities inside of JScript or VBScript. So that's one way to do that is the ACT-CTX object. It's really pretty cool. This one I like even more. It's something called registration helper. And so all you would do in JScript here would be say, create the variable with the System Enterprise Services registration class ID or program ID. And then you just say A install assembly, give it the DLL you want it to run. It's going to consume and load that and give you full access to the .NET API inside of JScript or VBScript. Again, pretty cool stuff. It does require a special binary. So you do have to have a couple of functions exposed. And that's on the GitHub page as a reference to. You have to have a register function and an unregister function. But you would give that, and essentially when you invoke that object and call install assembly, it's going to try and call this register function and then run whatever code is there. If you don't have administrative rights, it'll fall down and just run the unregistered piece. So you're able to use this to like bypass whitelisting, other antivirus type solutions. Pretty cool stuff. So now, this came out about maybe 3 weeks ago. And I'm not sure people really understand the implications of this, but this is really James Forshaw's work. And what he was able to do is, inside of a JScript file, serialize the .NET assembly to text, deliver that to the target, and then that will rehydrate, or you can create that in memory on the target and execute. There's no DLL left on disk. So we've actually been able to run Mimikatz entirely inside of CScript, WScript, Reg SVR32, full binary execution, full PE loader using this tactic. So this is really an important sort of game changer, I think, and I think Matt would agree. Like, this one really changed things significantly with what you can actually do with COM objects in JavaScript and JScript. So check this out on GitHub, .NET to JScript. You create a custom assembly. It has a little builder, turns out a text file, and then you can run that on another target. Really fascinating stuff. Okay, so I think we're gonna at this point switch gears a little bit. That's a little bit of the COM overview, some background. Hopefully that's helpful. Set the stage for some of these malicious tactics and methodology that Matt's going to go over. So I'll give this to you. Is this recording okay? We're good?
All right. Can you hear me okay? Awesome. Okay, so some of the methodology examples for abusing COM. We talked about earlier how things like Explorer, it primarily interacts with COM. So if you run procmon and start Explorer, you'll see it resolve a bunch of objects. So this is just a filter, an example filter for Explorer. We're primarily interested in load failures for HKCU. So from an operational perspective, what this means is that if you're going to abuse a COM object or you're going to hijack it, that's going to mean that your code's going to run and the legitimate code's not. Meaning if you hijack the COM object that displays all the icon files in Windows, the icons aren't going to show and things are going to break. So looking for load failures that exist already are good because they're not already loaded, meaning you're not going to impact the system when you run your actual code.
So we do this quite a bit. We just go in and control procmon and look for things that aren't being detected.
So this is what it looks like. Note treat as. We'll talk about this later. This is a cute one. So in proc server 32, we'll go over some of the keys, and how they can actually be abused from a malicious standpoint. So this is just what Explorer is looking for, all these different properties. They don't exist, so that would be a really good one to abuse. Okay, so some excavation tools. James Forshaw, again, put out oliview.net. Really good tool for looking at the existing COM objects, their interfaces, how they're registered. And it's really good for getting an idea of how, specific COM objects are actually registered and what methods and properties exist for those specific ones. And then sysinternals, procmon, and process explorer, both really good. They're Microsoft signed too. And believe it or not, they use COM too, so you can use those to perform COM hijacks. A lot of people have those on their system, so. Yep.
I think the other thing we would add here too is just exploring in PowerShell. We were talking about that. Like a lot of times you can create new object-com and give it the program ID and create those objects. So then explore the methods and properties that are exposed and see what might be interesting inside of those objects. So. Yep.
So the malicious tactics overview, we're going to kind of cover some persistence via COM, lateral movement, some privilege escalation, Office add-ins. So MWR put out a really good blog post recently that kind of highlights the use of this that I don't think's been publicly known or at least talked about. So we're going to kind of cover some of that stuff, how you might go about looking for other potential vectors in the same area. So we'll go over what we found. I'll be the first one to tell you that there's a nauseating amount of stuff to abuse in common Windows, and so this is a small percentage of it. So like Casey said at the beginning, we're hoping this is going to act as a reference for you guys. If you find this interesting, to go and poke around and expose some of the stuff that's out there, because attackers are using it. People aren't looking for it, so it really needs a light shined on it.
Yep, exactly.
So persistence via COM hijacking. There are two methods that I currently use for this specifically. One being treat as. So Microsoft introduced, there's a key called treat as for COM. What this does is it was designed to act as a layer of abstraction for old and new COM objects. So if there's a COM object that an enterprise has created that they use internally, but some service needs to use this older version and there's a newer version, you can add a treat as to kind of point. This specific COM object needs to resolve to this older version. What that means is that we can take an existing COM object, add a treat as key, and then point it to another COM object. So if you add a tree as key to wscript.shell and point it at the class ID for another COM object, when you instantiate wscript.shell, it's going to resolve the class ID. It's going to see that that treat as, and it's going to say, okay, I need to go over here and I need to instantiate this COM object. So it's a really nice redirect. The other one is COM handler hijacking. So Windows has scheduled tasks that run anytime a user logs in or anytime the system starts up. Attackers have been using scheduled tasks for persistence for a while. Most of it's been creating a new scheduled task or abusing some sort of functionality within the task itself. If you have anybody gone into a scheduled task and look at its action and it just says custom handler. So if you look at the XML in scheduled task, it has a custom handler set. What that actually is showing most of the time is that it's using some sort of COM object for its action. So it'll specify a class ID. You can hijack that class ID for a task that runs when a user logs in, and all of a sudden now you've got code running when that specific user logs in. You're not dropping any files down other than a registry change. So this is what the tree as persistence looks like. This is just a .reg, so they're just registry changes. The 3 ones to look at is backing, so you can back a COM object via the registry only. So we talked about some of the registration components and how you can register per user COM objects in the HKCU Hive. What this is showing is that we're creating our own COM object called Bandit, giving it a random class ID. And then there's a fun little one, it's called scriptlet URL. From the blue side, I've never seen this legitimately exist on the operating system. I don't know why it exists, but it does. So it's literally a web link to a hosted COM scriptlet. So you can throw that in there and then add the tree as key for this 373 class ID there. That's just a COM object that gets loaded or instantiated when a user logs in via, I'm pretty sure Explorer loads that specific object. So we're just adding a tree as key for that valid object to point to our newly created object that reaches out and runs a COM scriptlet.
Yeah, so when you hear COM scriptlet, think VB script from the internet.
Yep.
It'll actually be terrifying.
And combine that with the stuff that Forshaw put out for I can't even say the word. Yes.
Yep.
Words are hard. Yeah, so that essentially equates to, running full shell code. So kind of combining those two techniques makes for a really, in my opinion, a frightening experience. And I like Casey said earlier, I don't think people fully understand, the implications of this. This is a demo.
Yep. So this is a demo showing...
Sort of, or not.
Oh, hold on.
Uber fail.
We recorded
Yeah,
it.
we failed the demo and still we recorded it and still failed it. So. Okay.
There you go.
So this is just the same, registry entry that was on the slide that I showed you. Just kind of highlighting the COM scriptlet. This is hosted on GitHub. You can, if you want to type that out, you can go look at it. I could probably give you a link if you want to look at it. So just as a normal user, you can use reg, you can use whatever method you want to actually import those entries. User signs out. Like I mentioned, it's adding a tree as key to an existing valid object that's loaded by Explorer, pointing that specific object to our class ID that we created. And when that user logs back in, it's going to get executed relatively quickly. So, simple. Only things that change are a few registry keys. Everything else is, it's fetching something from the internet. So, okay. So Evasion, this is fun. There are a lot of components in Windows that rely on create and get object, much of which can be abused to our liking. So obviously combine COM scriptlets with get object, script object, and the script and scriptlet monikers. You can do a lot of really dangerous stuff. Specifically, VB script injection. This is humorous to me. I don't know that I would call it injection. On every Windows system, there's this thing called pubprn.vbs that exists. It's Microsoft signed. So it's got a digital signature that belongs to Microsoft. It's there. As you can see, we're running this script and we're giving it the script moniker, pointing it to just a Google short link to that GitHub that has a comp scriptlet hosted at it. When you run it, it runs our payload. So on the next slide, I'll kind of see why. Infinite Wisdom, they're taking an argument that you're passing to the script and calling getObject on it. Yeah, why? I don't know. So taking something user supplied and then literally calling getObject on it, meaning that it's gonna execute whatever you provide it as long as it's in the format it's expecting, meaning more or less a comp scriptlet.
Yeah, and this is a fun find because a lot of defenders, like from a red teamer, like a lot of defenders are now watching for red SVR32 or other techniques to execute. And so if you're doing like command line auditing or command line detection, this would be one to watch for now because you can run that VB script with a URL. Generally, URLs on command line would be worth investigating, but you're able to pass that remote scriptlet and get it to execute from the signed default, hub paren VB script. So it's pretty cool.
Yep, and that is without any changes to the registry. So the next example we're going to cover does require some user land changes. This specific one doesn't. So it's kind of a risk versus reward trade-off of, do I want to make changes to the system so that I can actually evade command line logging, or do I want to use this to, just inject what I want to execute within the actual argument? So this next example, we kind of talked about, COM looks in HKCU first as long as the integrity process is, medium. So a high integrity processor system is not going to look in the current user hive for obvious reasons. Insert asterisk there because there are certain situations where it will. But yeah, so this specific one is what we're doing is we're creating our own. So on Windows 7, if you go and look at the class ID, registry structure in HKCU, it doesn't exist. Windows 10 does have a few, meaning that there are some per user COM objects registered. Since Windows looks in HKCU first for the required information to instantiate the COM object, we can add what it's looking for. So it'll say, hey, I'm looking for scripting.dictionary. It's not in HKCU, so now I'm going to go look in HKLM. If we give it scripting.dictionary in HKCU, it's going to load it for us. That's exactly what this is doing. So we're hijacking a COM object that Windows is looking for specifically, and just giving it our payload via the scriptlet URL key that we talked about.
So, one thing, and Matt had mentioned this yesterday, just like make sure when you're hijacking some COM object like this, it's not going to be something that's going to break core functionality. You would look for some obscure COM object that wouldn't be referenced often. Scripting.dictionary is not maybe a good choice, but it's a good example for this. Yeah. This proof of concept to be able to.
Yeah, so Windows relies really heavily on COM. So if I've had instances where I've hijacked the wrong thing, and then all of a sudden nothing works, and I have like 320 calculators running, then you have to revert your VM, and it's a bad time. So tread cautiously there. So the way that this works is slmgr.vbs. This can go for anything that looks for a COM object. So we talked about persistence, how it was looking for this specific COM object when a user logged in, and we can hijack it. This is a similar thing, only this is in the aspect of getting around command line logging. So this is VB script that exists on Windows. It's signed. What it does, one of the first things it actually does is create scripting.dictionary to use. So if we create that in the HK current user hive, we create scripting.dictionary and give it the scriptlet URL to our payload. And keep in mind, you don't have to do scriptlet URL to the internet. So some people are like, well, I'm just going to look for network connections, and I'm going to look for comp scriptlets. You can, nproc server 32 is the key that actually points to the DLL that the COM it's going to look for to load the COM object. You can point that to your DLL. You can write your own DLL that has the exports it's looking for, and when it goes to load that key, it's going to run your DLL. This is just nice because you don't have to drop a binary on disk. This is not the only method of abusing it. So we create those keys, import them, and then now all you can see from a command line logging perspective, the only thing that started was slmgr.vbs, and our payload is getting executed. So all the malicious stuff's happening on the back end. when mgr.vbs runs, it tries to instantiate scripting.dictionary. It says, okay, I have this prog ID. Now I need to go in the registry and find its class ID and find what server I need to instantiate and all this stuff. Looks in HKCU and it says, hey, I found it. That's because we put it there. And instead of giving it what it needed, we gave it our payload and it gets executed. So, super neat. Does not change the signature of the file. Obviously, you're not modifying the contents of it or anything. So, most people are, from the command line perspective, are going to see this and not really think twice about it. So, a really good thing to look for would be, here are the scripts that exist on the systems. Here are the COM objects they're looking to instantiate. Maybe we should look at and see, are these objects being created in HKCU or not?
C script or W script making network cons would be another good indicator for somebody running these and fetching scriptlets from the internet. These are also good indicators.
So also a clever way to bypass app blocker. So Casey's done a lot of really excellent work on app blocker and getting around it. This is another clever way of circumventing it. Again, the same bug exists in multiple scripts. So the script that exists on Windows to set up WinRM does the same thing. It instantiates scripting.dictionary. It instantiates other objects as well. There are more scripts other than those two that instantiate COM objects. So if you guys are feeling froggy, you can go look at them and tinker with it.
Search file contents for create object, get object, and those are interesting COM classes that you could hijack in this situation.
Yep.
Absolutely.
Yep. So who's familiar with AMSI? So it's Windows 10. They implemented the anti-malware scan interface, and the idea behind AMSI, just a quick overview, was to kind of gain visibility at a very low level of what's happening for scripting components. So the Windows scripting host and PowerShell specifically. PowerShell has been this huge thing of everybody's using malicious PowerShell now. AMSI was introduced to kind of hook. So everybody's doing all this obfuscation, encryption, decryption, all this crazy, crazy stuff that takes time to develop. AMSI hooks right before the interpreter evaluates the code, meaning all of that encoded and encrypted content has to be decoded and decrypted before runtime. AMSI hooks, quote-unquote hooks, right before execution, meaning all that's already decoded and decrypted, and it can safely evaluate if the content's actually safe or not. So it's really solid. It stops Mimikatz and PowerShell for the most part. It hooks Windows scripting host. This is an example of where you can see that this pastebin link here is just it's a text document Microsoft put out that it's an AMSI test file to trigger AMSI. So what this works is when you start PowerShell, AMSI is loaded into the current process, and then when it gets to a point of executing code, what is actually happening is it's using a version of a COM object of itself to execute methods of scanning or evaluating the content that's being passed or executed. So what we can do here is that is the class ID for AMSI that it's looking to, it loads in the process and then it's instantiating this COM object so that it can scan the content. Because it's medium integrity, it's running on a user's process, it's looking at HKCU first, like everything else, meaning we can create that specific class ID by hand and then just point it at a random DLL. DLL doesn't have to exist. If you want to get code execution whenever AMSI tries to scan something, you can put that as a legitimate or not legitimate DLL. That would give you code execution whenever it tries to actually scan content, which is fun. This go away AMSI.dll is just a DLL that doesn't exist. So when it queries the inproc server 32 key, it's going to say, I need to look here for this COM object, and it's going to say, oh, this DLL doesn't exist, so it's not going to load. And it just fails open, meaning after we import this two really small changes, you can see now after we restart PowerShell, AMSI is reloaded into the process, and we reevaluate that AMSI test sample. We can see it no longer gets flagged by AMSI. I hope this gets fixed. They fixed all the other bypasses, so hopefully this one does too. So malicious Office add-ins. Again, I said at the beginning, MWR put out a really good article just a few days ago about using Office add-ins for persistence. You can go find the blog post there. there's been a lot of malware, so there are believe it or not, if you go and look at COM, there are COM objects for anything, more or less anything your heart desires to do in Windows. Who's familiar with the Outlook rule attack? So creating malicious Outlook rules to persist on a box. That's always fun because they wipe the box, the user sets their Outlook profile back up, and then all of a sudden the rule gets executed and you're back on their box. There are COM objects to interact with Outlook, Word, Excel, meaning you can programmatically create those rules via the COM objects. You can run macros, so Word macros, even if they're disabled without notification. If you have code execution on the system, more or less for persistence, you can execute a VBA macro via the Word or Excel COM objects, and it will run regardless of if macros are disabled or not.
So there's a couple links that John Lambert posted a good link of attackers actually using that tactic, so it's in there for reference. So.
Yep. And this is the...
Oh, yeah. All right, so this was really interesting. So privilege escalation, this was a CVE that came out earlier, I think it was in March. And so this was a COM object that you could create or request a COM object to be created, rather, in another user session. So this becomes really interesting when you're thinking about a terminal server or RDP situation where you have an aggregated box where multiple accounts are on, and a normal user happens to be on at the same time as, say, a domain admin or a help desk, somebody with more privileged access, request to run Mimikatz in their session, and it would work just fine. For example, create whatever process you wanted. So the way this would work, and I encourage you to read the details. The CVE is 2017-0100, found by James Forshaw, and I just borrowed a slide from his presentation to kind of articulate this pretty well. Over on the left, you essentially have a normal user, Alice, who requests, I want to create this particular COM object, which happened to have a property that would let you create a process in another user session. So when that came out, one of our colleagues, Julian, realized this pretty quickly. He was on an assessment, and he has a really good blog post that articulated, like, within a week of the patch coming out, like, in most organizations, there's a lag between patch, obviously, availability and deployment, right? So he was able to actually use this to escalate from a normal user account to a domain admin because he happened to be on a server 2012 box that was vulnerable to this. So it's really a fascinating abuse of functionality, if you will, for COM that has been fixed, but there are probably more of these situations that will continue to arise. So be sure to check out Julian's blog. He's on Twitter, Nopesled, if you want to check out some of his research there too. So that was really, how many of you have heard of that one or aware of it? Okay, so it's definitely, again, wanted to raise awareness for this one, a very recent bug that came out, so be on the lookout for that one. So, yeah. There you go.
Yep. So that kind of highlights, this from one edge of the spectrum to the other of the kind of abuse that you can take with COM. So you've got functionality abuse, some of the registry manipulation stuff that we talked about, all the way to the other end of legitimate vulnerability exploitation via a serviceable bug by Microsoft. So the attack surface for COM is massive. It's existed for a long time. It's full of legacy code, so it's not something people are looking at. I think Project Zero is starting to really kind of take a deep dive into it, which is really great because it's ugly and it really needs to be looked at. So lateral movement, this is another fun one. Back to kind of the functionality abuse. So lateral movement techniques have become relatively stagnant over the last few years. So you've got PSExec, WMI, kind of the standard trade-crafty things that attackers are using. Defenders catch on to that, and they can kind of tune their signatures down to the specific techniques. I don't like keeping things stagnant and getting signatured all the time. So it's a lot of work to kind of devise methods for getting around some of the static signatures, especially when it's based off of a technique. So veering or manipulating a technique is kind of difficult. So I set out to kind of find an alternate way of getting code execution remotely. Since we are looking at COM, there's this thing called DCOM, which is just the distributed component object model, and it's essentially remote COM. It's over RPC. You have to be authenticated for the most part. So there are 3 objects that I identified. There are more. So again, I encourage you to go check this out. There are 3 objects that contain interesting methods. I don't have a slide after that. Okay. So yeah, 3 interesting methods. They're all the methods are shell execute functionality, meaning you can pass it, it's literally shell execute. You can run binaries, you can run commands, you can run whatever you want. This is exposed over DCOM. The reason that this works for these 3 objects, 2 of them are, COM objects that interface directly with the Windows shell. The other one is the MMC snap-in. So, if you're going to connect to Event Viewer instance, the Event Viewer instance remotely, you could do that. You can open MMC or Event Viewer.msc, connect to a remote computer, and it just magically works. That's what's happening. So these objects don't have explicit launch or activation permissions. I don't know if this is on purpose or if it was oversight or what the deal is, but the vast majority of COM objects or DCOM objects have explicit launch or access permissions set, meaning administrators aren't allowed to remotely instantiate this object. This specific, permission set's allowed to only instantiate, but not, do X, Y, and Z. So it kind of locks it down a little bit. These objects don't have any set, so it falls back to administrators can instantiate and activate and kind of interact with these objects remotely. What that means is we can instantiate these objects remotely. Given it's a lateral movement technique, so you've got local admin on the system already. This is just a different way of getting code execution. It's not using like WMI or PSExec or any of that kind of standard stuff. So what you're seeing here is we're just using .NET to get the type from the class ID. And we're giving it the class ID of the object we want to abuse and then an IP address. And that's going to be, it's going to instantiate that object on the remote host and return us back a handle. So if you do that and then you list the methods and properties for that specific object, they will be for the remote computer from your current instance. So create the instance. This particular one requires you instantiate an item. This is a portion of the Windows shell. It has other interesting methods and properties like is service running, so you can check and see if a service is running. You can stop a service, you can start a service. There's a lot of functionality for things you can do with Explorer that you can do remotely via these objects. One of them specifically, I don't know why this exists, document.application.shell execute. You just pass it command line parameters for executing a remote shell command. So this is just example. We got cmd.exe, waxc, calc.exe, and it runs calc on the remote host. Pretty straightforward. Again, it's RPC, so the firewall does kind of tinker with this. There are ways around it, but the Windows firewall does relatively it restricts which objects you can abuse and how you can abuse them for DCOM. I often see people disable the Windows firewall because they're running Symantec's firewall and it's uber elite and Microsoft's isn't, as their excuse. Every single time I've used this via some sort of AV firewall or custom other firewall, it does not prevent this for some reason. Another thing to consider is admins need to be able to remotely instantiate stuff as well. So admins that are using MMC snappings to connect to computers to view scheduled tasks or view event logs or do whatever they want, they have to allow DCOM in, and that's a pretty common configuration thing in the Windows firewall if they are using the Windows firewall. Places will often explicitly allow DCOM and RPC in, which means you can abuse this as much as you want. So, any questions on that?
How did you determine the class ID to use to do this?
So I use James Forshaw's oleview.net to go through the DCOM objects. And I was just looking for specific ones that had no explicit launch or access permissions, and I just went one by one and instantiated them and recursively looked at all the properties and documents, or properties and methods that existed. So this one was kind of buried, document.application.shell execute. The class ID, when you identify these two objects, I don't think specifically that one, the other Explorer one, they don't have prog IDs associated with them. And so in James Forshaw's tool, you can view the class ID for that specific object and just instantiate it that way. There's also, you've got get type from class ID. There's also a .NET method for get type from prog ID. So when you're doing new object-com, and then the prog ID for a COM object, that's what's happening on the back end. And so you can kind of manipulate that to kind of, instantiate it remotely if you're tinkering with different objects and you might be onto something that allows for some sort of remote interaction.
All right, so now, what does all this mean, and how are we feeling about calm? So we wanted to again draw attention to some of the tactics that adversaries are using with calm, give you some tool sets to explore and learn maybe how to research and find some of these on your own, and hopefully provide questions, be a reference. So there's a lot of good links in here. Like I said, we'll post. We had some code earlier. We're going to release a Git repo later on that has all these different samples. The reason we have those samples is for you guys to be able to run and test and look for indicators and look for things the way it may show up in your environment. So those are tools that you can use to test, like running the VB scripts that we hijacked or testing COM hijack. So I think we're doing really good on time. Just a couple of shout outs again. We really thankful for James Forshaw and his research. I encourage you to follow him on Twitter. Look at his Git repos. He's done some amazing work with COM research. Also, some of the former team members at ATD that helped us with our research and also gave us some feedback on this talk before we presented it. So I hope this is helpful. I think at this time we'll open it up for questions. So if there's any questions, let us know. First question gets a book. Oh, there we go. All right. Come see me after. So.
Does any of the reference material go into detection tools or methods in more detail? Or?
I don't think we have a lot of really good references for detection. It's more on creation and locating those objects in the registry. So as far as like detection at scale or detecting across an enterprise, I don't have any really good references for those. It's a good question, though. So
one thing that you can potentially look at is at least monitoring the current user software classes TLS ID path and look for any new creations. Windows has the OneDrive's registered there on Windows 10. Any new creations or additions outside of what you typically have in your enterprise would be something to potentially look at. Specifically ones that are looking for scriptlet URL. That should never exist, and if that exists, you're about to have a really bad day.
Yeah, that's an indicator of itself, just that even the scriptlet URLs, like Matt was saying, never really used. So I haven't seen anybody using COM scriptlets like for production use. Like we use them for POCs, but like if you do, please let me know. I'm curious. But I haven't found anybody that needs those XML documents that can be run inside of other containers, if you will. So
there's like one article on the internet from like 1995 about it, and that's it. So.
Yeah, pretty fascinating. So there's another question here somewhere. Yep.
Yeah, with the hijacking, where you're injecting into the HKCU, and you were talking about by doing that for the malware detection, and you said there wasn't a fix for it. Would the fix be something like not even checking HKCU and just checking HKLM or something? Or what would a fix be for them to do?
As far as the AMSI stuff?
Yeah.
Yeah, so his question was, for AMSI, would a fix be checking HKLM and not looking at HKCU? The answer is yes. That's not something as a Windows consumer you can probably do. Obviously, a detection mechanism for that would be look for that specific class ID being created in HKCU. It really kind of falls on the Microsoft of how Windows overall resolves COM objects. So in order to fix that, they would have to more or less address the larger problem of COM looking in the current user hive, which isn't really fixable because there are legitimate per-user COM objects. They could potentially prevent, so there are some objects that prevent you from creating them in HKCU. If you go to create it in HKCU, despite having full access to that specific hive, and you go to create the class ID and it tells you access is denied. Windows Defender does that. So if you try and hijack the class ID for Windows Defender, it tells you to go jump in a lake. AMSI doesn't. So I would expect Microsoft, if they end up addressing this issue, would be to put restrictions on adding that specific class ID in the current user hive.
Yep. Good. Other questions, feedback, comments? Yes, question here.
So when some of these things like calculator, you launch calculator, does that show up in the process table or is it showing up as something else?
It's a good question. So some situations like where you're running like in all those examples like calc would be the child process of like C script or W script or regsvr32. So if you're creating the process, if you're creating a child process using like W script shell run or exec, but some of these tactics like earlier on the .NET and JScript, it would all stay in the same process and show up as the trusted binary. So you would just see C script running. And you wouldn't see Mimikatz, for example, in the process list. So you're fully in memory of that process that consumed that COM scriptlet. Does that answer the question?
For the lateral movement stuff, if you're using the two objects that kind of interface with the Windows shell, those processes you're spawning remotely execute as a child of explore.exe. So if you're running something, calculator.exe is not going to look weird running as a child process of Explorer, right? So that's another thing to kind of be wary of in that regard.
Yes, question.
When you were doing the privilege elimination, that was requiring that the higher privileged user had to log in
At the time. Yep, same time. Yeah, so think of somebody running that in a loop that just waits and listens. Yeah, but you're right. You'd have to have that simultaneous connection for that particular CVE to be triggered. Yep. Other questions? Well, thanks again to BSides for having us, and thank you guys for coming out, and we'll be around for questions. I think we're between you and lunch, so enjoy your lunch. Thank you.